Hi children, welcome to World of Chemistry. In this class, I am going to discuss atomic structure. So before going to atomic structure, being first class, I will speak you generally a few minutes. Later we will start that atomic structure. So before born all of us, earth born. And before all of you, animals there, water is there, birds there. After that only we came onto this earth. So in the process our forefathers tried to understand what is there in nature, and they are trying to understand the beauty of nature, how this earth created, how this plant created. In that process, scientists nearly struggled more than 100 years to explain about this atomic structure. More than 100 years struggle to know about atomic structure. It's not a single day or 1 year struggle. More than 100 years. Of course, in this era, 100 years, more than 100 years. Before this Kali Yuga, so many yugas there. They also tried many times. Anyhow, just 100 years from back, more than 100 years, what the struggle scientists there to explain about atomic structure in detail, and whatever that struggle to give students in easy manner, a teacher requires 40 to 50 classes based upon the grasping level of students. But I am going to give you within 4 minutes about that final conclusion of atomic structure. This is the main point. So most of the students in colleges, as they are coming newly into the college atmosphere, feeling more difficulty in understanding about atomic structure. Nothing in atomic structure. Even the scientists struggle of more than 100 years. Even a teacher discuss more than 40 classes. Only the main point you should keep it in mind is one point. What is that? The shape of an atom is spherical. You just keep it in mind this one. So the shape of an atom is spherical. In spherical shaped atom, at the center nucleus is present. In spherical shaped atom, the shape of an atom is spherical. In spherical shaped atom, at the center nucleus is there. At the center nucleus is there. Around the nucleus orbits. This is the nucleus. In spherical shaped atom, at the center nucleus is there. Of course, nucleus contains protons and neutrons. Around the nucleus orbits or shells present. Around the nucleus orbits. Around the nucleus orbits or shells. Orbits or shells present. Around the nucleus orbits or shells present. Now these orbits or shells again contains suborbits. Suborbits or subshells. Suborbits. So how many electrons there? As of your knowledge, you, what's your name? You, what's your name? As of your knowledge? Huh? Gajan. Okay, as of your knowledge, how many electrons there in p orbital? 6 you say in p orbital. In d orbital? 10. It is wrong. In f orbital? 14. So whatever you done, all are wrong answers. So number of orbitals in number of electrons in p orbital is 2. Number of electrons in d orbital 2. F orbital also 2. So what you say that the number of electrons in p orbital is how many? 6. D orbital 10. F orbital 14. So that is wrong. Number of electrons present in, as of your knowledge, up to what you learned in 10th class. So as of your knowledge, you saying that it is 2 electrons, but any orbital number of electrons present is 2 only. Either s orbital or p orbital or d orbital or f orbital. The number of electrons present is how many? 2 only. So for that, after the struggle of more than 100 years of scientists and the teacher struggle of more than 40 hours, the final conclusion, what is the final conclusion? First you keep it in mind. Later we'll discuss in detail about that struggle. So just within 4 minutes the conclusion of atomic structure. The shape of an atom is spherical. In spherical shaped atom at the center what is present? Nucleus. So the shape of an atom is spherical. In spherical shaped atom at the center what is there? Nucleus. Around the nucleus what are present? Orbits or shells. Orbits or shells. Orbits again contains suborbits. Orbits again contains suborbits. Orbits. So orbits. Orbits. Orbits again contains suborbits. Orbits again contains suborbits. Sit down. Suborbits again contains what? Orbitals. Orbitals contains electrons. Orbitals contains electrons. Even though scientists struggled more than 100 years, though a teacher struggled more than 40 classes, the final conclusion of atomic structure you should keep it in mind. In spherical shaped atom, at the center nucleus is present. Around the nucleus orbits or shells present. Orbits or shells again contains suborbits or subshells. Suborbits or subshells again contains orbitals. Orbitals contains electrons. So generally orbits means 1, 2, 3, 4 like that. In first orbit S subshell is there. Second orbit S and P subshells there. Third orbit SPD subshells there. Fourth orbit S, P, D, F subshells are there. Now again subshells contains orbitals. S contains 1 orbital, P contains 3 orbitals, that is Px, Py, Pz, and D contains 5 orbitals, Dxy, Dyz, Dzx, dx square y square, dz square. So here orbital means, p orbital means either px or py or pz. So what I asked you before in the beginning of class, how many electrons there in Gajanand? So in the beginning of class, what I asked you, how many electrons there in p orbital? You answered that it is 6, but not 6. P orbital, the maximum electrons in p orbital is 2. The maximum electrons in d orbital is 2. The maximum electrons in f orbital is 2. The maximum electrons in p suborbit, if I ask you, for example, just actually, so the final conclusion of this atomic structure, see here, orbits. So orbits here, orbits. So orbits means 1, 2, 3, 4. Orbits, see now, orbits again contains suborbits. Suborbits, you try to understand, suborbits. Suborbits here. Orbits again contains suborbits. 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 Yes. Here the suborbit SP. Here the suborbit SPDF. Sorry. This is SPDF. Suborbits. Suborbits again contains orbitals. For example, P contains, I am going to write this another table. Suborbits again contains orbitals. Suborbits. Now suborbits. Suborbits contains what? Orbitals. Orbitals. S contains one orbital. For our convenience, I am going to represent the orbital as a box. Actually, orbital is a three-dimensional. The shapes of orbitals you will learn in the end of this class, end of atomic structure. Anyhow, for our convenience, I am going to represent the orbitals as a box. S contains one orbital. P contains three orbitals. P contains three orbitals. 1, 2, 3. This is Px, and this is what? Py, and this is Pz. Sp. D contains 5 orbitals. D contains 5 orbitals. 5 orbitals. So dxy, dyz, dzx, dx square, y square, dz square. F contains 7 orbitals. F contains 7 orbitals. So what I asked you, now orbitals contains electrons. Orbitals. Each orbital will give accommodation maximum 2 electrons. Maximum 2 electrons. Any orbital you take, either px orbital or py orbital or pz orbital. Right? Any orbital will give maximum accommodation. Any orbital will give 2 electrons. So p orbital maximum. See here one point, most of you, if you listen, you will get clarity. In the beginning of the class, what I asked you, how many electrons there in p orbital? You answered that 6. When will that 6 answer is right? Maximum electrons in p suborbit. P suborbit, then 6. That is the right answer. P suborbit is a combination of 3 orbitals. D suborbit is a combination of 5 orbitals. F suborbit is a combination of 7 orbitals. So maximum electrons in F suborbit, then 14. What you said, that is right answer. Maximum electrons in D suborbit, then 10. That is right answer. But maximum electrons in D orbital, 2 is the right answer. Maximum electrons in d orbital is 2. That is right answer. Maximum electrons in d suborbit 10. That is right answer. So don't take that suborbit and orbital both same. So suborbit is a combination of orbitals. So anyhow, the final conclusion about atomic structure, scientists struggled more than 100 years to explain only this one. What is that? Once again, so in spherical shaped atom at the center nucleus is there. Around the nucleus orbits or shells present. Orbits or shells again contains suborbits. Suborbits again contains orbitals. Orbitals contains electrons. You may arise the question, sir, why this much of time? More than 100 years. Yes, atom we can't see with our naked eye. We can't see the atom with our naked eye. Though we are not able to see the atom with our naked eye, we can find so many things about atom. That's why scientists take more than 100 years. And for a teacher, how that scientists struggle to explain that struggle, teacher requires more than 40 classes. Even after 40 classes, this is the conclusion given to you. Now we are going to discuss about in detail the struggle of scientists. Step by step. Of course, it will take 40 hours. No problem. Okay, anyhow, before going to that detailed study of scientists more than 100 years struggle, let us see some basics which you already learned in 9th and 10th classes. So that based on that basics, we can understand very clearly about this atomic structure. So before going to that, listen here. First of all, a list of elements. A list of elements for you to understand conveniently. Here you observe, this is the skin, right? This is the skin. This skin is made up of carbon element. This skin is what? Carbon. Are you able to see this skin? Yes. This skin, you pick some skin. This is nothing but carbon. So now I am going to divide this small pick of this skin into thousands of pieces. Then are you able to see that carbon? Then are you able to see that small piece? No. So which you can't see with your naked eye, right? You sit down. Sajaran, go to your place. Then if you are not able to see with your naked eye, why you not? You take this skin, carbon element, right? Carbon element. We are able to see. Carbon element we are able to see. But carbon atom we can't see. You take it, you divide this skin into millions of pieces, small part of. Then we are not able to see. That much of smaller is the atom. Now what is the difference of atom and element? Can you say atom and element? What's your name? Vishnu. Chatta.
Yes, sir.
What is the difference of atom and element?
Sir, atom is the
Atom and element. So hydrogen atom, hydrogen element. Carbon, see this one, carbon. Carbon atom, carbon element. Carbon element, the element definition. Carbon element. Element means a group of similar atoms. A group of similar atoms. Group means Pranit. What's your name? Pranit. Pratik. A group of similar atoms. Group means, you know, in mathematics very well. Group means 10, maybe 100, maybe 1 lakh, maybe 2 lakh. A group of similar atoms. A group of similar atoms is called element. So element, hydrogen element. So before going to in detail about atomic structure, let us see some basics. Then you can understand. Then you can understand easily. Right? Name of element: hydrogen element, helium element, lithium. Hydrogen element is H. Hydrogen atom.
H plus.
Hydrogen atom.
H2.
Hydrogen atom is H. Symbol of hydrogen. See, right? Symbol of hydrogen element is H. Symbol of hydrogen atom, you tell me.
H.
H only. Symbol of hydrogen element. Symbol of hydrogen atom, H only. What is the difference? As symbol of carbon element, C. Symbol of carbon atom,
C.
What is the difference? What is the difference of atom and element? Only I discussed element, a group of similar atoms. There is a chance we can see a group of atoms. One atom we can't see with our naked eye, but a group of similar atoms. Group of similar atoms definitely we can see. So group means it may be 10, 1 lakh, 2 lakh, 1 million, whatever it may be. So a group of similar atoms, Lokesh, a group of similar atoms is called element. So these are the elements. So in generally elements, atoms, symbol and see in generally the symbol of atoms and elements is same. But atom means one. Element means a group of. So first of all definition of element, a group of similar atoms is called
element.
A group of similar atoms is called element. Now name of the element, atomic number, mass number. So first you learn, being a chemistry student, everyone should by heart like your name. Elements for total first year and second year intermediate. For total first year and second year intermediate, you need a few elements. So these are hydrogen, atomic number 1, mass number 1. Atomic number is denoted as Z, mass number denoted as atomic number denoted
Sir.
atomic number denoted by Z, mass number denoted by A, mass number denoted by A, mass number denoted by A. So these are the tell.
So is there any way to remember name of elements and atomic mass simply, sir?
Simply,
Sir.
don't go for that any simple technique. You go for like this one. Better you learn.
Start.
Okay. Fluorine 919. 9 is the atomic number. 19 is the mass number. Here, everyone should learn. Up to 20, everyone should learn atomic number, mass number, what is the important or what is the use of learning atomic number and mass number, that we will discuss next class. So after 20, calcium 20, 40. After 20 you should learn chromium 24, 52, manganese 25, 55, iron 26, 56, next copper 29, 63.5, bromine 35, 80, silver 47, 108, iodine 53, 127, barium 56, 136. You just go through it. Or we have to learn list of these elements. A list of these elements. List of these elements. You should learn. That's all. In the initial stage, you learn atomic number and mass number of up to these barium. Whatever I gave after calcium, that only enough. So now what is the importance? So you may ask the question, sir, what is the need to by heart? What is the need to by heart? This atomic number and mass number, Vishnu. That is your that only in your mind, that only running. Sir, why should by heart? Okay, anyhow, though atom is a right, though atom is a smallest, even we can't see with our naked eye. Though atom is the smallest, even we can't see with our naked eye, atom still contains nearly 100 particles. Out of 100 particles, 3 particles are important. What are that? Electron, proton, neutron. Electron, proton, neutron. For example, lithium. For example, lithium atomic number. For example, lithium atomic number 3. In lithium, how many electrons there? 3. How many protons there?
7 minus 3, 4.
3 only. In lithium, how many electrons? 3. How many protons?
3.
3. If you by heart atomic number, you can easily say the number of electrons and protons.
What about neutrons?
Wait, we will discuss. So, suppose nitrogen, atomic number 7. How many electrons? How many electrons? 7. How many protons? 7. So, fluorine, how many electrons?
9.
How many protons?
90.
9. Electrons 9. Protons 9. If you by heart, see, in the atom, fundamental particles are electron, proton, neutron. To know how many electrons, protons, neutrons are there in the atom, you should by heart atomic number and mass number. For example, lithium. Right, listen, lithium, last one. Lithium, atomic number 3, mass number 7. Atomic number 3, mass number 7. See here I am writing like this. Lithium. Here I am writing like this. Lithium. Atomic number, atomic number 7 and mass number, atomic number 3. Atomic number 3 and mass number 7. Li is the symbol of lithium. Li is the symbol of lithium. 3 is the atomic number. 7 is the mass number. This is called nuclide. 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 What is nuclide? The symbol. Li is the symbol of Li is the symbol of lithium. The symbolic representation of an element. Here element. The symbolic representation of an element with atomic number in the subscript. This is subscript. And mass number in the superscript. So the symbolic representation of an element with atomic number in the subscript and mass number in the superscript is called nuclide. 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 I hope you got the definition of nuclide. Suppose nuclide of beryllium. Nuclide of beryllium. How you write beryllium?
9.
Beryllium. Atomic number. Atomic number 4. Mass number 9. This is what? Nuclide. Otherwise, simply you can write like this. Simply you can write like this. Simply you can write. Simply you can write X, Z, A. Where X is the, assume that X is the symbol of element. X is the symbol of element. Z is the atomic number. A is the mass number. You note down the definition. Nuclide. Most important. A nuclide. What is the definition? The symbolic representation of an element with its atomic number in the subscript and mass number in the superscript is called nuclide. Is called nuclide. That's all. Next we are going to. Okay, thank you. We'll continue next class.